First off, we want to go ahead and say thanks for everybody for coming out. We have a little interesting thing and a play on words, but some interesting tech for people to actually develop with Kubernetes and specifically in cloud native. So you see a box down here, and I'll explain that in a second because maybe you should know who we actually are. So myself, I'm a developer for Arch Linux ARM, and yes, sure, you see the nice little orange tag, so I'm also an employee at GitLab. I work with Kubernetes day in, day out, but I also work with ARM hardware day in and day out. In my spare time, I continue to contribute to other open source projects, and a random high impact change that I can say that I've done is that -BIP flag for Docker, which inadvertently fixed all kinds of interesting things for software-defined networking that I would never know I did, except for the fact that Cisco VPN annoyed me enough for me to make that flag.
My name's Will Christensen. If you've ever seen any of Jason's previous talks, he does one called Angry Noob Syndrome. I am the Angry Noob he based that on, so hello. Started out as an electrical engineer, started getting into software, and so I ended up wearing many, many hats, including mixing software and administration, embedded systems, you name it. For a few years ago, I was a Windows developer, and then after a swift kick in the rear from Jason and some motivation, I got into Linux administration and broadened my horizons.
Yeah, and as a matter of interesting fact, he actually used to deploy .NET applications into OpenShift. That was an interesting challenge, and that was a really fun one for me to try and help him with while he was at it. So let's run down. We've only got a certain amount of time. So what we're going to try and do here is we're going to use Rancher's K3S, and we have a cluster of ARM boards. Not this one, because I couldn't hook it up. We're going to run Arch Linux ARM on that. We're going to install a load balancer inside of that cluster, and then on top of that, we're going to deploy an application and actually show you all the steps and parts of what a Kubernetes app for cloud native actually is. Then when we're done, we're going to go ahead and commit that up to the public project that we already have in place so that anybody can follow along. If we have a little bit of extra time somehow, because hey, live demo, then we're going to go ahead and actually try to do some persistent storage. We're going to talk about the difference between x86 and non-x86, and some of the other things that you can do as a part of the tool set that we've put together here. So, first off, we'll go ahead and talk about the OG here.
Okay, so the OG BuzzCrate is 6 hard kernel Odroid C2s. They're available for about $45 each, depending on where you're finding your vendor, not including like anything like power, that kind of stuff. There is a parts list that we do have available for both of the systems, but the one on the left just has, 8-port gigabit switch, some fans to keep the cool, and then it's using USB power supplies in order to supply the 5-volt rail for each system. You want to talk about LibreCrate that you're showing off in a Nike box?
Yeah, so when we talk about BuzzCrate, everybody know the concept in the tech world of buy this crate, that, right? This is basically one of those things. Obviously, we're not selling it. Might be a business model, but one of these days. Mm-hmm. The joke is, for sub $500, you can build yourself a development cluster that you can have and not have any operational expenditures afterwards, that you can go ahead and build full cloud-native applications on your desk for a line item less than the cost of a couple of monitors for your desk. Try passing $2,000 for a baseline Kubernetes-capable server past your boss. Not going to happen. This guy fits in a shoebox. I can make 2 of them in here, and for less than $500.
All right, so go back.
So we're going to go through, tab.
All right,
and I hand it over
demo
to Will.
time. So I'm literally going to bounce through DO, back home.
Everybody can see where font size is good? Yes? Okay, yes,
we'll make it a little bigger.
A little bit bigger? Control plus?
I did. One more.
Okay, good? All right. So the first thing we're doing, by the way, his cluster is still at his house near Philadelphia.
I could have brought it with us, but DNS issues every time we move it.
Yeah, I'm not sure how he always breaks his DNS. It's not like it's a, oh wait, yes it is.
I use chaos engineering.
Yeah, well. So we're going to go and bounce back to that one. He has this entire cluster set up with Ansible. So for those of you that wonder, oh, how can I actually spin up an entire Kubernetes cluster in a nice, clean, programmatic infrastructure as code? Hey, look, we have workable code for you.
And we will be committing this exact code at the end of the presentation.
We're going to skip the joys of Ansible because he knows it, I don't. And that's a whole other talk.
But this entire project is designed to be two things. Accessible from both a financial perspective, as far as Basement Lab is for having a cluster at home. And it's designed so if you don't know Ansible, if you don't know, or if you're not comfortable with the command line, or if you just want to play with Kubernetes, but you don't want to play around with whatever Kube Spray and cloud, that kind of stuff, it's designed to be accessible, available to you. We like Arch, and the Arch philosophy, I will bring up a little bit later with some of the containers if we have time, is really what kind of helped drive the simplicity of the installation, and allowed me to get container sizes that were native, that I could build myself, down to about 200, 250 megabytes, where if I were trying to grab, let's say, a basic Python container from, Docker Hub, when they have their multi-Arch support, it's almost a gig for that. And each one of these nodes, at the time of us building this, hardware only limited us, or what was available on the market, was about 2 gigabytes per node. So we kind of had to finagle it. I actually built this cluster over 2 years ago, but the amount of RAM required by Kubernetes to run was so high until Rancher released their K3s cluster, which simplified it, stripped it down, made the installation a lot easier. They have binaries available, which we are using, you can find from the PKG build, in order to install an ARM natively. And it starts the conversation of what does it take to build a cluster?
Right, and we're specifically using K3s here because a master node takes only a half a gig of RAM, so we've got a lot left over, and individual nodes take only 128. Who's ever spun up like 15 nodes in GKE and realized that you only have 3/4 of the RAM you thought you did? Full-blown Kubernetes is heavy. We're intentionally running this on low CPU, low RAM nodes, so that you can see the difference in performance between something that's in a constrained or high-load environment as opposed to something that's given the entire range of a brand new Xeon processor in some data center somewhere. The second thing is, for a low single cost, you don't have to deal with whether you can get an account, whether you can get it past all the approvals or any of these items. You can build it, test it, run it, and you can know that if it runs well on this, if you put it in production with high CPU and RAM, trust me, it'll run. Not only that, it'll run extremely well.
Okay, we have a cluster built in that time. It actually took me a little bit longer to run a little script that made sure that I could run kubectl locally from my desktop that deployed it with Ansible. If you are smart, you can actually use the master or one of the nodes as your Ansible host to apply it across the entire cluster if you wish. But it makes the general install a little bit more difficult. So now that we have this, we almost have a cluster ready to deploy our app, and also one of the repositories that we have in the BuzzCrate group. Cluster, there we go. Is for installing Metal LB and anything else that we felt that was necessary for getting the cluster up and running. So if you haven't used Kubernetes before, once you get kubectl working, we have just 2 files in here. Just going to be, there's a README for a basic example, the deployment, and a configuration for it. Configuration's already been done. We'll make sure that's all checked in later. There's already a version already from the previous conference we went to. Mm-hmm.
There are a few updates from the previous conference because, hey, revisions happen. They will be checked in, like we said, at the very end of this presentation. So the first thing we're doing is we're installing Metal LB. This actually, we're operating in layer 2 mode. The reason this works is that we are actually allocating a section of the land that's controlled by this particular cluster so that we can use real load balancers. That's often a problem when you're using on-premise, is that how do you get a load balancer? Where does it come from? Do I have to have an external controller for that? Because we have a very static known behavior for this cluster, meaning it's behind a small router and it's attached to a switch and it's just these things on it, we know that we have the ability to go, you know what, give me all of the, say, 200s, and I will use them for load balancers. So you can actually have that feeling of, give me a load balancer in the box and in the cloud.
All right, so we have the load balancer here. I'm just going to get this up and running so we can see the application deploy. Get pods. Now, one thing I need to mention is that all these containers were made without Docker.
Namespaces.
Oh, namespaces, yeah. All right, so while that's running, sample apps, and we have a basic one that is literally just Golang, just a little Echo server, a little web page that it produces.
Now, what you're seeing here is we're actually going in and building out everything out into a very simple container. We're not going to build that container right now just because of the particular amount of time that we have, but this container is actually built using Builda instead of actually using Docker. The reason being, does anybody know why? Privileged containers in Kubernetes, what's the danger of that? I'm getting a few Well, the nice thing is that using Builda or Kite or Kaneko, you can manage to build containers without actually having to make use of Docker in the privileged mode. And Docker in DND or DOOD, don't even get me started, there's headaches involved with those, one of those being a massive security issue. So the demo is specifically designed so that it's also secured by default.
All right, we have a working container, but, well, it looks pretty skookum, but let's see if it chooches. Let me do a kubectl get.
So what we've done at this point is we've gone ahead and actually put a deployment out there, and then we've stuck a service in front of it so that we can get a load balancer. And of course, we've all done this by hand before, right? Simple service, throw the thing. Who actually uses a web browser for the first call? Okay, maybe most other people, and I'm just kind of a CLI guy. But we curl that, and sure enough, we get back the echo, because that's all it was. It was a very simple Go binary that does echo.
Anyone can do what we just did with minimal knowledge. Now, question from the audience is, we have some options here. We can deploy a Flask app. We can discuss how to build a non-x86 container without Docker. We can show you the archway, which is also showing how to build it without Docker. Or we can talk about Ansible. So any
preferences?
So raise a hand for Ansible. One for Ansible. Any more for Ansible? No? All right.
Okay, 1, 2-ish.
Three?
Kind of 3.
All right, cool.
Anything
all right.
else?
How about Dockerless builds for containers?
1, 2, I'm seeing
all right,
preference
that one's
for
going to win.
Dockerless build.
Okay.
So we've got 7 minutes. I think we can do that. Let's go for it.
All right, yeah. So let's actually go someplace where we can show them exactly what's going on. So we're going to go to the alarm cluster. So in the sample apps that we have, there's going to be a folder in there. Yeah, we're going to make that bigger in just a second. Let's just go to Go Echo. Really basic, really simple. In each folder, you're going to see image builder. I built everything using Builda. And just to make sure it wasn't going to be too difficult, I called it Builda-me. Now, what is required, if you're going to build a container, you need to do, especially if it's non-x86, is either be on an emulated or actual hardware to have the binaries that are compatible with it. So I normally pick one of my nodes. I make sure when I go to build that I shut off the Kubernetes agent or node before building, because then it's a resource contention. But other than that, this is all shell script. There's the one thing that really kind of shows what's going on here is we're building from scratch. And then in order to make the container, and this is something that is available with anything that's an OCPI, container standard. If you mount it and you just take what you make for like a chroot, change root, shroot, however you want to call it, if you have that same concept that you repeat, and it doesn't matter if it's Debian, it doesn't matter if it's Arch Linux. Arch Linux is easiest with Packstrap, but it doesn't matter what you're using. You mount the folder and you just throw your binaries in there, and you essentially make a remote repository where that folder is located. And that's it. So for us, on line 10, Packstrap, it's literally going to throw some basic things in there. I literally just grabbed file. I was experimenting, trying to make the smallest container possible. I found out I could even make it smaller just by finding one file or one package. All the necessary dependencies were installed immediately in the container. Then I just copied over the web server, which is a previously built Go application that you saw one
everybody
run with
knows
Perl.
this one. This is just add.
Unmount it, and then everything else from 14 on is just config stuff for the container.
So obviously what you're seeing, as a shell script, we're calling build with a single argument, and it just additively puts all of these things together, right? So you can do this in shell, you can do this by hand, it depends on how you choose to do the actual implementation. But instead of the Docker way, which is actually create a layer, do a thing, create a layer, do a thing, create a layer, do a thing, Builda can take a static point, create that as a base, and then you can do all your operations, and at the end say, now I have a layer.
Now,
Where he did use the mounts, that's effectively the same thing as from image. Okay?
Yep. And the nice part is, if you use the methods I use, which is just grabbing something from the base repository that we have, if you are in a secure environment, you can go talk to your security guy who wants to scan your container, say it's not safe. If you are using the same repositories that your system is using, be it AWS, be it a local machine, a VM, whatever, it's
UBI
going to be
images.
hard. Yeah, you just have to, you're going to be arguing, being like, why are you scanning something that you've already okayed? This is silly. So here's a slightly bit more complicated container. This is the one which is a Flask app. This does not include the database. It's a PostgreSQL database. I did pull that from
Docker Hub.
Yeah, it's a Docker Hub. And really it's just simple, which is it's a Packstrap. I have BusyBox in there for getting in there and having command line, Python, setup tools, pip, certs, that kind of stuff.
Basically I need a Python runtime and I need to be able to use SSL, so please.
Yep, and as long as you're running these commands with Builda on the same architecture that you are going to be deploying with, then it'll work. But yeah, it's just really simple, and if you notice that there is a pip install with the requirements, I do have to copy that over. When I go to run build a run, I am actually, it's similar to like a Docker run, it will actually launch the container, build it up. But not until I do a commit will I actually save the state of the container.
That's the new layer, is when you call commit.
Yep, that's when I'll write, that's when it's saved, that's when you can recall from any point it is set in stone. And that's how you build containers. If you want to do, IBM has been pushing, a lot of stuff with their PowerPCs, that kind of stuff. This is the same process that you would use if you want to go on PowerPC. If you want to check out other hardware platforms, just assume Linux underneath is set up in a way that you understand with the binaries. You will be able to build containers and have them running in no time. Running the container engine like Kubernetes. I think OpenShift should be available, but we should see what's going to be available for Kubernetes on IBM at least. But
they're working on it.
Yeah, but when MIPS or some other software comes around, we'll have it.
Okay, well, that pretty much sums up our time for the day. But we want to just say thank you to the companies that actually sponsored some of this hardware, Rancher Labs for the work when it comes to K3S, and Southeast Linux Fest for giving us the opportunity to completely test run this and completely screw it up the first time because live demos, but also to the projects, again, that actually do this with open source hardware, open source software that enable us to do crazy things like clusters and boxes. If there's any further questions, we will be around, but thank you all for coming out, and I hope you've found something of interest and something that you can really use in the future. Thank you.